What if the future of AI isn't some gradual, slow evolution, but a sudden, massive leap that's just around the corner? Today, we're diving into a really groundbreaking essay from Leopold Aschenbrenner, who used to be a researcher on OpenAI's safety team. And it gives us this rare insider's look at what the people actually building this tech see coming in this decade. It's a pretty stark prediction and one we really need to get our heads around, so let's break it all down. This story, as the author puts it, really begins in San Francisco. It's the epicenter. It's where the conversation has totally shifted from just hype to what he calls a full-blown industrial mobilization. This isn't just another tech trend, you know? This is a race that's already reshaping our world, right now. So the whole premise of this essay is that while basically everyone is talking about AI, only a tiny circle, maybe just a few hundred people inside the AI labs, truly get the speed and the scale of what's about to happen. They're the ones who trust the trend lines. So our job today is to pull back that curtain and see what they see. Okay, first things first. The idea of artificial general intelligence, or AGI, has completely escaped the realm of sci-fi. Aschenbrenner argues it's now an active, incredibly high-stakes industrial race that is happening as we speak. The starting gun has officially been fired.
And this race? It's being fueled by an almost unimaginable amount of money. The key here isn't just the huge numbers, but how fast they're growing. We're talking about boardroom plans that are apparently adding another zero to their investment every 6 months or so. This is a mobilization of industrial power we just haven't seen in generations.
So how in the world can we predict where all this is heading? Well, the author says the key is to stop thinking in terms of years and start, as he puts it, counting the ooms. That's the fundamental unit the insiders are using to measure AI progress.
And an is pretty simple. It's an order of magnitude. It just means a 10x increase in something, like computing power. And here's why it matters. For every of effective compute we throw at these models, they just predictably get smarter. So if we can count the we can get a real sense of what the future looks like.
To really get what this looks like, let's just look at the jump we all just witnessed. In only 4 years, we went from GPT-2 to GPT-4. But what does that leap in capability actually feel like?
The author uses this absolutely brilliant analogy. GPT-2 was kind of like a preschooler. You were just impressed it could string sentences together at all. Then, just 4 years later, GPT-4 is like a smart high schooler who can ace AP exams and write pretty complex code. I mean, that was an insane jump in intelligence. And the trend lines? They suggest we're about to do it all over again.
So how'd we make that jump? Well, it's a mix of 3 things: way more compute, better algorithms, and something the author calls unhobbling, which is basically just getting better at unlocking the AI's existing smarts. The math shows that the leap to GPT-4 was a jump of about 5 to 6 OMs. And here's the stunning part. The projections show we're on track to make that same size leap again by 2027. So we're not going from a high schooler to a college student. We're talking a leap to an expert PhD coworker. And this is where the story escalates, like dramatically. The author argues that progress isn't going to stop at human-level AGI. The very next step is something called the intelligence explosion. The tipping point comes when AGI gets good enough to start automating the very process of AI research. When that happens, you create this recursive feedback loop where smarter AI builds even smarter AI, and you end it compressing decades of progress into a very, very short amount of time. Think about this. Right now, a leading AI lab has maybe a few hundred top-tier researchers and engineers pushing things forward, okay? Remember that number, a few hundred. So here's how that feedback loop could play out. Once AGI can automate its own R&D, we could see a decade's worth of algorithmic breakthroughs happen in just a single year. And that triggers this rapid transition from human-level AGI to something vastly superhuman. Superintelligence. Because once you have one AGI that can do research, you can run millions of copies of it on those massive GPU clusters that are being built. That small team of a few hundred humans suddenly becomes the equivalent of 100 million AI researchers, all working 24/7. That is the intelligence explosion. So what does it actually take to power this future? This isn't just happening in code. This is a race to mobilize America's industrial might on a scale we can barely imagine. The physical scale here is just hard to comprehend. Forget millions or even billions of dollars. By 2030, the author projects a single AI supercomputer could cost over $1 trillion and need more than 20% of the entire U.S. electrical grid to run it. That's not a server farm. That is national infrastructure. And that brings us to the challenge. The author points out that to meet this insane demand, the U.S. has to start building again, big time. This chart really illustrates the gap. In the last decade, China has built as much new electricity capacity as the entire existing U.S. grid. Meanwhile, U.S. capacity has been almost flat. So when you have stakes this high, trillions of dollars, national energy grids, world-changing power, the author argues this whole race cannot stay a purely private sector thing for much longer. And that argument is captured perfectly right here in this quote. The sheer power, the incredible security risks of superintelligence, it's just beyond the scope of any startup, no matter how much money they have. And the reason why is this fundamental mismatch in security. A startup security, he says, is like Swiss cheese. It's got holes because it's built for speed. But the secrets to AGI, those are national secrets. They require Fort Knox-level protection from state-sponsored hackers. The two models are just completely incompatible. So the crucial point this essay builds towards is this. Eventually, the U.S. government is going to have to step in. The race for superintelligence, with its immense national security implications, will almost inevitably become a national project, a lot like the Manhattan Project was for the atomic bomb. And that leaves us with this one final, sobering thought. This isn't just some wild speculation from the outside. This is the perspective from inside the labs, from the very people building this future. They see the trend lines, they're counting the ooms, and they truly believe this is where we are headed, this decade. The only question left for us to think about is, what if they're right?